Hi Intro to Calc, this is section 5.2. So the past couple days we've spent some time talking about the area that's under a function, and so sometimes that net area can be positive and sometimes it can be negative, and we have talked about areas of rectangles and trapezoids, and so that's all been really nice because all of the areas have been these pretty formulas that we're allowed to use. So what happens when you have a curve? So we could have a curve like this, and we could think about the area under that curve. So a long time ago, people would approximate that with rectangles, and you can actually do it with trapezoids, but I'm going to show you rectangles. And so you can make your rectangles really big, or you can make your rectangles really small. And I hope that you see that if your rectangles are really, really narrow, that more rectangles would fit in, and therefore you would get a better approximation. So you could potentially have an infinite number of rectangles, and that would be a limit if you let the rectangles have a width that went to 0. And that is another calculus idea, because limits are all about calculus. So if we let the area under a curve have a lot of rectangles to fill up, then that would give us the precise area. So this is something that you would spend a little bit more time in like a Calc 1 course. So for us, we're just going to go straight into the exact area. So the exact area is the definite integral. And it looks like this symbol right here. We don't call it an S, we call it the integral. And it stands for an infinite sum. So just like we were saying earlier, there could potentially be an infinite number of rectangles, all with a very, very, very extremely narrow width, such that when you added up all of the rectangles, you would get a precise area. So this stands for an infinite sum. And we have a lower bound, and we have an upper bound, and that tells us the region that we're trying to find the area between. So for example, in this problem right here, we would start at an A value here, and we'd stop all the way at this B value. And you would put the function on the inside. So relative to this example right here, you would just be, this is a fancy way of saying add up all of these rectangles, and the heights of the rectangles would end up being f of x. So what does this look like in problems? So I'm going to start us here. Again, what this represents is the function, and you're finding the area under that function, so under 7, between 2 and 5. 7 is a horizontal function, and it says specifically you are finding the area between 2 and 5. And so this is a really, really nice rectangle. The rectangle is 7 tall, and it is 3 wide, so the area is 21. Number 2, we're trying to find the area, I should say the net area, under this line right here. So we have a y-intercept of 8 and a slope of -2. So down 2 over 1, down 2 over 1, and I'm just going to keep going with this pattern. And you can look right here at the bounds, and it says find the area between 0 and 4. So we don't need the full line, we just need this region right here. I see that as a right triangle, so it has a base of 4 units and a height of 8. So I use 1/2 times base times height for my right triangle, and so that area is 16. Number 3, another line. We have a y-intercept of 1, go up 1 over 3, up 1 over 3, etc. And you could keep going forward and back, but you see that the bounds are from 0 to 9. So I'm going from here to here, and that represents a trapezoid. So my area is 1/2 times the height, which is 9. times the sum of the bases. So 1 plus 4. So this is 1/2 times 9 times 5 is 45 over 2. And that represents that area right here. Number 4. This looks like an intimidating function, but it's really not. And so I'm just going to go back to geometry for just a second. When you were in geometry, your teacher probably taught you that this is the equation of a circle. And so when we rewrite this equation for y, I'm just subtracting x squared, and now I take the square root. Technically, because you're taking the square root, you need to have a plus or a minus. Root 9 minus x squared. So all this represents right here is a circle. And the reason that it's a full circle is because of the plus and the minus case. The plus case represents this piece right here, and the minus case would represent the bottom portion, and together they would make the full circle. So the graph that you see here in number 4 is just the positive part. It's the top piece. We have a radius of 3 because in a circle the basic formula is this. So if r squared is equal to 9, that means r is equal to 3. So I'm going to do a quick sketch of a circle, and I'm only going to do the top half. And this function says, this integral says, find the area between -3 and 3. The area of a circle is pi r squared, and this is a half circle, so I divide by 2. So my answer is 9 pi over 2. Number 5 is very close to what we just did. The only thing that's different is that we have this plus 3. So that is a shift. It's going to take your entire half circle and it's going to shift up 3, just like you did in transformations in Algebra 2 or in pre-calc. The entire function gets shifted up 3. And so what we have here is that same half circle that we just calculated, and we also have a rectangle right underneath it. So I'm going to steal our answer from previously, so that's 9 pi over 2. And then I have to add on the rectangle because it created a rectangle by increasing the y values. So the width of it is 6 and the height is 3, so I add 18. Number 6, the function is 4 minus absolute value of x. Remembering what your transformations were like in previous courses, the absolute value function is a v. And so this is reflect over the x-axis, and then it's also going up 4. So it should look like this. It's an upside down v because it's been reflected over the x-axis, and then the entire graph goes up 4. So now the integral says add up the area between -2 and 4. So I see a trapezoid, and then I also see a right triangle. So the trapezoid will be 1/2 times height times the sum of the bases. And the right triangle is 1/2 times base times height. So 6 plus 8 is 14. And that's it for the first day of 5.2.